So dy for this problem will be 1 over the square root of 1 plus t squared multiplied by the inner function prime, which is 1 over 2 the square root of 1 plus t squared, multiplied by the inner function prime, which is 2t. Any questions? Yes, I will simplify, and of course, I just said that, multiply by dt. And of course, I will simplify by 2. So then the differential of y, which is extremely important for chapter 5, differential of y is t dt over, when I multiply these two, I get 1 plus t squared. Okay, let's look at another. What about y equals 1 minus v squared over 1 plus v squared? Same question. Dy will be f prime of x dx. I don't have x, I have v, but that's okay. So then dy will be the top function prime, negative 2v times 1 plus v squared, minus 1 minus v squared times the bottom prime, times dv, of course, over 1 plus v squared squared. Yes, I have to simplify it fully and present dy simplified. Okay, I will factor out 2v, of course, even negative 2v. So dy is negative 2v. Okay, so I took out negative 2v, so I have 1 plus v squared. I took out 2v and negative, so it's plus 1 minus v squared. So the differential of this function is negative 2 times 2 inside is negative 4v dv from here over 1 plus v squared squared. Okay, let's look at something like we're given y equals e to x over 10. We are given x equals 0. We are given dx equals 0.1. The question is asking us to find dy and also evaluate it for the given values. And evaluate it for the given values. Okay, no problem. Dy will be, again, f prime of x dx. So then dy equals e to a power e to x over 10 multiplied by the inner function prime, which is 1 over 10 multiplied by dx. So now I will plug in. When I plug in 0 for x, this is 1, and dx is 0.1. So dy equals 1 over 10 times 0.1. So this is 0.01. So that's dy. Any questions? Any questions? Okay. I would like to look at, let's say, y equals 2 over x. We are given x equals 4, and we are given delta x equals 1. So they say, find dy, and of course dx is the same with delta x. Okay? And also find dy. So they want delta y dy, knowing that x and delta x are the same. Okay, so if I want to find delta y, I have to remember that this is f of x plus dx minus f of x. Okay, x plus dx, this is 5. So this is f of 5 minus f of 4. No problem. It's 2 over 5 minus 2 over 4. Of course, I will factor out the 2. And I have the least common denominator will be 20. So 4 minus 5. So I will simplify. So the numerator is negative 1 and the denominator is 10. Or negative 0.1. Now they want us to find dy, which is f prime of x dx. So dy for our function 2 over x is negative 2 over x squared times dx. And now dy equals negative 2. X squared is 16, and dx is delta x, same thing, 1. Okay, so this is negative 1 over 8, or negative 0.125. Quite close, as expected. Okay, I think we have time now to go back to another problem. I have one question quiz for you. It should take a blink. So I think we have time for another word problem from 3.9. Yeah, interesting. Here it is. We have a particle that moves along this curve, y equals 2 sine pi x over 2. As the particle passes through the point, so the graph of sine is something like this, and here's a point 1, 1/3, 1. So as the particle moves along this curve, and this is the curve of 2 sine pi x over 2. As the particle passes through this point, its x coordinate increases at a rate of the square root of 10 centimeters per second. And you'll tell me what this is. How fast is the distance from the particle to the origin changing at this instant? And you'll tell me what we're asked to determine. They are trying to trick us. They're intentionally giving us this point at the beginning of the problem. But we will not fall for it. So let's read the problem one more time. A particle moves along this curve. As the particle passes through the point, its x coordinate increases at a rate of the square root of 10 centimeters per second. How fast is the distance from the particle to the origin changing at this particular instant? So, we disregard the point. We say the particle is anywhere, and this is the distance from the origin. This and this both have meanings. So this is the graph of that triangle. This is W. Of course, this must be X and this must be Y. And yes, of course, this is a right triangle. So what is given to us? And what are we asked to determine? Anyone? So this is specifically dx over dt, and what we're asked to find is dw over dt when some information is given to us. So like before, we have to create a relationship, and the relationship is the Pythagorean theorem, which is w squared equals x squared plus y squared. We had something like this an hour ago. We differentiate implicitly. So these are three functions of time. We differentiate the left-hand side to w dw over dt, and that will equal to x dx over dt plus 2y dy over dt. Yes, we'll divide both sides by 2, and I will solve for dw over dt, which is x dx over dt plus y dy over dt over w. And now let's see what we have and what we don't, what we need, etc., etc. Any questions so far on this problem? Very similar to the very first one. So dw over dt, when x is 1/3 and y is 1. So x is 1/3. Dx over dt is given to us as the square root of 10 plus y is 1. Dy over dt, which we have to determine, and w, which will be the square root of x squared, which is 1/3 squared, plus y squared, which is 1. But here I have to find dy over dt. Okay, so I go back to the function. Here's the function. Y equals 2 sine pi x over 2. So dy over dt equals 2 cosine pi x over 2 times the inner function prime, which is pi over 2, times the further inner function prime, which is dx over dt. These two will go away. So now I have pi cosine x is 1/3, so this is cosine pi over 6, and so I had pi, I had cosine of 1/3, so this is pi over 6, and dx over dt is the square root of 10. Sorry that I had to squeeze it in there. Okay, so I will rewrite it again, because cosine pi over 6 is the square root of 3 over 2. So the whole thing now, one more time, dw over dt will equal. I can take the square root of 10 outside for now, 1 over 3 plus pi times the square root of 3 over 2, and over that whole thing, 1/9 plus 1. So the 1/3 is there, pi is there, the square root of 3, and the square root of 10 is outside. Calculator, be very careful. We need parentheses around the numerator. I will also put parentheses around inside the radicand. Okay. The square root of 10 can be outside. If you're okay with that, it's okay. Left parenthesis, 1 divided by 3 plus pi, the square root of 3. Make sure you're outside of that. You can write divided by 2, close the parenthesis, and divide by the square root. And I will put in parentheses depending on your calculator. This one doesn't need a parenthesis, but I got used to them, so I just can't disregard that. And plus 1, and close the parenthesis. And most, not most, but many of you still have the older version, so I have to show that anyway. So I got 9.1621. Now we have to establish the measurement unit. We have to write the measurement unit. So it was the rate of change of distance from the origin right here. It changes exactly when the particle passes through this point, but we cannot use that point from the very beginning. So everything is given in centimeters. So this must be in centimeters per second.